So today we're going to be talking about the final method for being able to solve a system of linear equations that we'll be working with this year. We do have a little bit more to do before we get to our final test, but this is going to probably for a lot of you give you a method that you really enjoy working with. Elimination is different in substitution in that we're going to be adding or subtracting two equations together simultaneously. So some rules. One, we've got to make sure that our x and our y and our equal signs are all lined up vertically as we list the two equations. We're going to force one of the variables to have what we call like coefficients. That's when the number, it doesn't matter about the sign, but that's when the number attached to the variable is exactly the same for both x's or for both y's, or whatever other letter we're using. We're then going to add or subtract to cancel out that variable, which will leave us with only one variable to solve for. We'll get an answer, plug it back into an original equation, and then solve for the other variable. Again, as always, we will make sure that we write our answer in coordinate form. So let's take a look at our first example. This example I've designed in such a way that I'm going to solve it two different ways just to demonstrate how the adding subtracting idea works. So the system is x plus y equals 12, my first equation, x minus y equals 2, my second equation. You'll notice that they all have the number 1 as their coefficients. So the first way I'm doing it is I'm adding the two equations together. I'm adding them vertically. I get 2x equals 14, x equals 7. I take that 7, plug it back into equation number 1, and I get my solution. If I were to subtract the equations, the x's would cancel out. 1y, take away a negative y, make sure you carry that subtraction in to the rest of the equation, gives us the 2y equals 10, I go and solve, I get the same idea. So adding will cancel out opposite signs, subtracting will cancel out same signs. Got a little bit of a frozen screen there. Here we go, next example. Suppose I have 3x plus 5y equals 11, and again, these all represent lines on a graph, and 6x minus 15y equals negative 3. There's multiple ways I could do this one, but I'm going to cancel out the x's. So I'm going to take the top equation, multiply it by 2, every single piece. I then subtract, I get an answer of y equals 1. I plug it back into one of my original equations. I'm choosing equation 2 this time. I get x is equal to 2. So my solution is 2, 1. Line up your variables, line up your equal signs, add or subtract depending on what will cancel out something, and then solve. Example 3. Here I'm going to choose to take the first equation, multiply it by 5, and I have to also take the second equation and multiply it by 2. So it's kind of like finding a common denominator. In this case, I get both of them are 10x's. I subtract, I get y is equal to 2. Plug that back into an original equation, solve for my x value, and I get x is equal to 4. 4, 2 is my solution. I think you get the idea. Homework is on page 437. If you have questions as usual, feel free to let me know, and we'll meet again on our Zoom lesson later on this week. Goodbye.